So hello everybody. That is the August Clojure data science meeting. And if that is okay, then let us mute ourselves as much as possible while others are speaking. And maybe in a moment we will hear ourselves discussing some stuff. In the first part of the meeting, we will have a few of very short talks by several of us. And afterwards, we will have a discussion. And the idea is mainly to catch up, to hear a little bit about the projects which are going on the ecosystem we are building, and to see everybody here. It is heartwarming because, of course, it is an unusual time and people are having the private local struggles, and being here matters, I think, for us looking for for us looking for a way to somehow make sense of what is going on. So I think at least for this community, we can have good hopes for the coming weeks and months, and let us discuss that a little bit later. So now what we are going to do is to have a sequence of short lightning talks where people will be telling what they are about, what they have been building recently. And I guess we will try some method where each person may speak for 5 minutes, maybe less if they wish. Less is also good. And we will use a gong sound so that people can know about where time passes. The gong will be heard in the beginning, and then after 3 minutes, 4 minutes, and 5 minutes, so that you can see where it is starting to end. And the first person to speak will be Anthony Kong about the new Spark wrapper he has been building. And I'll just let us hear the gong for a moment. Is it okay? Could you hear it? Yeah. Okay. So that sound will happen at the beginning after 3 and 4 and 5 minutes. And more people are joining. And so, Anthony, are you ready to begin?
Yeah, except that I think you need to enable screen sharing. I've brought myself some slides. Yeah.
Perfect. Perfect. Here I am allowing that. And now you can share, and let us begin.
Okay, please let me know once you can see the screen.
Yes, we can.
All right, great. So, okay, first of all, thank you so much for having me. Since we only have 5 minutes, I'll just cut to the chase. So I'm talking about Guinea. So this is a Clojure data frame library that runs on Spark. So two things that I want to cover today. One is I'll tell you what it is, and also some design goals that go into it. So let's go to what is Guinea. First thing to say about it is that it's an idiomatic Clojure data frame, right? So what I mean by idiomatic Clojure here is that it should be nice to read and nice to write. And also being a data frame library, it does what you'd expect it to do. You can, you require it, you load data, and then you can do your count, and you can look at your columns, for instance. And all of this just runs on Spark. So this is an example of doing a group by and aggregate. And when you show, you can see the results here. Being run on, being hosted on Spark, you get Spark ML for free. So there's a reasonably rich machine learning library that goes with it. So this is an example of how you'd create a pipeline, machine learning pipeline. And then it's just a matter of like ML fit, ML transform, just like what you'd expect in scikit-learn. There's also RDD support, which just means that you can do lower level Spark if you like. The next thing I want to say is that so it's not just a library, right? It comes with a command line interface as well, which comes with a standalone REPL or for you to submit script. So it's a bit like Spark Shell, where when you fire it up, you get the, you don't need any requires, you get the data frame, you get the library there required already. So that's like a brief tour of what Guinea is. So some design goals. I think the overwhelming objective of the project is to provide an environment where you can have fast feedback from the data. I think this would be familiar with for a lot of data scientists, where you're constantly living in this cycle where you get some idea about your data, and then you're doing some query, and then you'll get the result, and then you build on top of that idea, you'll get new ideas from that. So the idea is that we want to optimize this feedback loop. And some important factors is like kicking off the feedback cycle. So it must be fast for you to start doing it, and then translating your ideas to queries, and finally your query speed, right? And fast and accessible REPL is one of the design goals that we're trying to hit. And the use case for this is like spontaneous queries. So for instance, like you're working on a data set and you're thinking, okay, what's the most expensive region in Melbourne, right? So I think Python is really good at this because it starts very quickly, and then you just do import pandas as PD. You read your Parquet file or whatever file you store it in, and then you do your query and you get the answer. That's fine. Basically, we want to be able to do the same thing, but with Clojure. So that's where the Guinea CLI really comes in. No need for line new, line run, no need for requiring this and or that. You know, it starts up and then you're good to go. It's only a little bit slower than Python in this case. And the second thing is about translating your ideas into code, right? And one thing to say is that it has to be nice to write. So there's nothing stopping you from writing interop code such as this one. This is like pure Scala interop, right? But then it's not good because it's quite verbose, and a lot of these queries would be short-lived, right? Like the lifespan is like under 1 minute. And if you have to write a lot of throwaway codes like this, it's really not nice. So with Guinea, you can write this instead, which is a little bit cleaner and shorter. And it has to be nice to compose as well, so that instead of getting Scala data structures, you want to get Clojure data structures so that you can plug it into somewhere else. So G-collect here, you get a sequence of nested maps. Query speed, this is like a very quick, dirty benchmark that I did. It's like resembling a project that I did recently this year. But Guinea is fast, right? It's fast out of the box. It can be up to 70 times faster than pandas, and seeing like 30x is quite typical. There's some other libraries there as well. I think that's my 5 minutes. I hope that piqued some interest, and contributions are welcome. Thank you so much.
Thank you so much. That last benchmark was amazing, and we will discuss it further soon.
Sure.
Yeah. Okay, so now I will briefly show some Clojure workflow. So I will share my screen, and what I'm trying to show in this workflow is a couple of tools that are growing these days. And what we are seeing here is a node space, which is an experimental way to connect the REPL and browser and the Emacs editor in this case, but any editor eventually. And we will see how we can try to connect all these tools in some dynamic way. And what we have here is a certain Kaggle avocado dataset, which we are reading thanks to the tablecloth library, which is a wrapper of the XML dataset. And a tablecloth allows us to do pandas-like processing of data frame nature. And the visualizations we're having are by some part of the Pink Gorilla ecosystem, which allows a certain DSL for viewing data in using certain JavaScript libraries that are wrapped by that DSL. And what we are also having here is some UI element, some user interface that can control our REPL state. So for example, what we are doing here is using tablecloth. We are taking all the avocado sales in Seattle and grouping them by type. You see conventional and organic, and looking at some statistics of price and volume. And we can filter these, and we can see that if we take a minimal volume, which is big, we have only conventional. And if we change it a little bit, then we have organic too. And all that is happening in the REPL state, so with some thin layer connecting to the browser. And the magic behind the scenes is not only some parts of the Pink Gorilla ecosystem, but also the CLJFX library, which offers some really neat way to manage state in the JVM Clojure. And I encourage you to look into it. So we see here tablecloth and Pink Gorilla, and also behind the scenes, the TechViz library that generates Vega specs for visualization. And all these compose in pure data transformations. And that is what I wanted to show, how these few libraries can connect. And the point is that it is now very easy to see how things can easily connect with very thin layers. So it is very easy to experiment. And let us talk about further experiments on how REPL state, browser state, editor state, and your minds can connect together. So thank you. And I'll stop sharing now. And, oh. So now our next speaker will be John Anthony, who will show some updates about Scicloj.
Let me see if I can get the screen share here.
Yeah, sure.
Oh, have you got, can you see that?
Yes, we can see.
Okay, so I'm just going to give a quick overview of what this is, and then a little bit about Shiny, and then how to do Shiny-like things in Scicloj. So Scicloj is basically it's a self-contained interactive built environment for exploring data and creating and saving visualizations and creating shareable interactive documents. Actually, the presentation, this is a Scicloj document. There's some features. There's main editors. Main editor is like this stuff over here, which can put, and then you create the document that's on the right. Those editors can create code, visualizations, markdown, LaTeX, reactive components, automated boilerplate. Has a powerful template substitution system borrowed from Hanami. It's not cellular or modal or linear like typical notebooks. Doc body editors can be live and interactive. You can directly mix code from Clojure and Clojure script and R. Python is in the works. Multiple namespaces so that you have a single document, you can have different data scenarios captured without having to reload everything. And you can organize documents along chapters and sections, which is sort of like what this tab stuff is. Shiny. Shiny is an R system for visualizing R computations. It uses the web. It's a push-based design. R code generates HTML and pushes it out to the client. in the browser. And it's intended to be a simple and easy way for our users to visualize stuff that they're working on. Key aspects relevant for today is the processing is server-based, so you can leverage all the capabilities there. Front end, it provides for user interaction, and it has high leverage components for widgets and charts. And I think this is probably a big one, this bit here. So a couple of simple examples. Here's an introductory lesson, first kind of shiny app thing. And then here's your code, which is fairly straightforward. You have these very high abstracted components for the widgets and stuff. Okay. This thing is killing me. Okay. So Chrome is okay. And then here's an actual interactive one. Well, okay. Well, maybe this is going to be too long. Eventually, this will come up. So in Scicloj, what we need to do the similar kind of thing is data computations to the server. That's not a problem. You can use Neanderthal, TechML, or Guinea. Visualizations are provided via Vega, Lite, and Vega. Could be others. You can have very high leverage via templates, the substitution system. And reactive components are currently, it can be other things, layered on Recom and Hiccup. And you can, but we need a higher leverage for these things, and we can abstract widgets via the template system as well. So that's kind of cool. So let's just pull up an example. We won't have time to do maybe any more than this. So this is running code. And here's, if we come back over here quickly, maybe we can see, here's the shiny version of this. And should be able to update this stuff a bit. Yeah, so that's going on. And then you can, every time you do these clicks here, you're going out to the server, it recomputes and then pushes a new version of the visualization. Here, we're not doing that, we're pulling things, but we can just move this around in exactly the same way. These are, again, calling out to the server, and we can do the same thing here with this. This stuff is, we open this up and take a look at how we did it. We have these high leverage components, slider input and text input, that creates this, and then another one that creates the exact same thing here. We leverage ourselves on top of Vega and Vega Lite to do this stuff. And is the gong telling me I'm out of time? Say yes or no.
So these are 5 minutes, John. So slowly you can go to the ending if you wish.
Okay, so I got a little bit of time left. Well, okay. So let me try and load this other one, which is a little more interesting in terms of its capabilities. So again, these widgets are just, let me take a quick look at the widgets. We go over here. This thing is loading all kinds of stuff, but the definitions are in these, like here's a single drop down, a selection list. We have a slider input, all this stuff. If we come over here, we can use this and change our states. We can update the computation for the sliding window, average. You can come over here and look at the similar kind of thing, only this is per state. Let's update this. And again, these things are all done in exactly the same kind of way as with that other one. So we have our slider input, the text input over here. So that's this piece right here defines this entire stuff. So it's a fairly high leverage thing. And maybe that's it. Thanks.
Thank you so much, John. So that was magnificent. And so we have seen now earlier one way of building dashboards through the REPL state. And now you showed us what may happen when one uses the browser state. And that was really magnificent. And thank you so much. And so the next speaker will be Mike. And to everybody who have joined us recently, thank you for your patience. We are now having this short sequence of lightning talks, and afterwards we'll have a short discussion. Mike, would you like to share your screen?
Yep, let me find the right window here. That one is PowerPoint. Second. Hang on a second. Why am I having trouble here? Share screen. Okay. Hang on a second. There we go. All right, people see that? Okay. Oops. Yeah, all right, I'm going to get started. So I'm going to talk about Inflame, which is a visual query builder against an atomic knowledge base. So the domain that I work in is in cancer immunotherapy. So cancer immunotherapy is a new technique for treating cancer that leverages the body's own immune system. The Parker Institute does research into this process. We're trying to understand and make it better. The only thing I can say here is that the immune system is really complicated, and there's just an incredible diversity of data and things we want to represent. So we built a knowledge base called CANDLE, Cancer Data and Evidence Library, based on Datomic. So we ingest experimental and reference data to organize it into a common framework and provide it as a tool that researchers can use to query. So as a knowledge base, it's a kind of medium complexity. This is a graph of all of the classes involved, and I don't know if you can read that. So some of the central classes are there's subjects or patients, samples, which are tissue samples that we get from patients, and measurements where you run some experiment on a sample and see what's in the genome or other measurements. So there's about 30 or so classes in CANDLE, and then genes are another important data type that are sort of central. So we have genes and gene variants, and the samples are linked to that. So the one question is we have a lot of users of this database who aren't programmers. How can we make it possible for them to query the database? Here are some typical queries scientists might want to ask of this, such as what are the outcomes of patients who have renal cell carcinoma, who have variants in PBRM1, which is a particular gene, when treated with anti-PD-1, which is a particular class of drug. How do responses vary by gender and body mass index across cancer types, things like that. And they can get fairly complicated. So that's some background. The other background is kind of, sorry to switch gears fast, is so Scratch is a children's programming language that some of you may be familiar with. It's a visual. It's a tool designed for children that makes it possible to compose programs by snapping blocks together. It came out of the MIT Media Lab. There's a bunch of similar systems, including Blockly, which comes out of Google, And so what my big idea was to hook up Blockly with Candle to make a visual query builder, and I'll show you what that looks like. And the system is called Inflame, because everything we do is candle related. So this is what Inflame looks like. There's a construction space where you pull out blocks and snap them together and make a query. That query gets translated into data log, and then you can view and browse the results down here. So for instance, here's a typical query a scientist might want to do: find subjects with stage 4 cancer who have variants in gene PBERM1. So to build a query, you kind of sort of identify what are the entities you're interested in and their classes, and then you pull out blocks that represent those categories and snap them together. So this is a block translation of that query. You find subjects. There's a query block for finding the subjects, and then inside of that, there's various constraints on what the subjects can do, and you can have subqueries in that. It's it's fairly straightforward. This is part of the block construction process. Looks like this. You have all of the 30 classes are here. They each have a color, because we all have about 30 classes. We're sort of pushing the boundaries of what you can do using encoding and color. Then there's blocks for each of the to query the subjects, and for each of the properties a subject might have. And some of those blocks come with subqueries of their own. Here's an example of a blocks and its translation into data log. Here's a somewhat more complicated example. You can see you can also do things like counting and control some of the data that's returned. Yeah, to describe some of the details. So like I said, classes are mapped to color. You have some blocks have a little output nub, which indicates it produces a set of objects. And then query blocks have this gap, which is I'm sort of abusing some of the Scratch metaphors, but that's a way you can add multiple clauses that basically you can put in query constraints and they get ANDed together in there, as you can see down here. Here we're querying for subjects. Race and drug. How am I doing for time?
So these were 6 minutes. If you wish.
All right, I'm about done. These are some of the underlying components. It's in Clojure script and Reframe and Datomic. We're using the Blockly library from Google. There's a part of this has been there's a library called Blockoid, which we've open sourced, which is a wrapper for Blockly. So now it's relatively easy to create block languages in Clojure scripts. I encourage anyone interested in that to make their own. And then here's some of the other people who work with me at Parker on this. That's it.
Beautiful. Thank you so much. And we need to talk about it more slowly one day. Really,
I'm sorry, is there time for questions in the end, or can I ask questions now?
let us have questions later, if that is okay.
All right, wonderful.
So the next speaker will be Christopher Small. And
cool.
Yeah,
let me share my screen here. Okay, does everyone have that? Cool. All right, let me go ahead and start here. Hi, everyone. Thanks for being here. I'm excited today to be showing you an environment I've been working on for analyzing scalable open-ended feedback as produced by Polis, which is a digital democracy tool for engaging citizens in decision-making processes. So the first thing I'll show you here is just the repository is up on GitHub under POL-IS analysis. So if you'd like to take a look and play around with some of this data, welcome you to do that. It's got instructions for running and everything here. Right now, I'm going to just go ahead and kick off the Docker image here. And sorry, I missed a piece here. Right, so really what this has in it is a Docker container which has a bunch of analyses that have been built upon TechML dataset, libpython CLJ, and visualizations built using Oz and Vega. And all of this comes together in sort of two form factors. One, custom Clojure kernel for folks who like kind of the traditional, Jupyter notebook style environment. And additionally, a set of Oz style analysis notebooks, which I'll be showing a little bit more in a second here. So kicking this off with Docker Compose, we down at the bottom.
Could you maybe zoom in a little bit?
Yeah, and actually I need to make it smaller before I make it bigger because I need to click on this link and it won't work if it's on multiple lines. But down at the bottom here, it'll once we run this, we'll get some URLs printed out for opening up the Clojure, well, the Jupyter notebook. And now that I've got that, I can make this a little bigger. So once we're in here, we can go ahead and click through to notebooks, Jupyter, and there's a Clojure example here.
A little
and I won't,
okay.
a little bit more. Yeah, sure. So I'm not going to go into anything in too great a detail here, just that it has some basic examples of loading up TechML dataset and libpython CLJ, requiring some of those Python libraries. Yeah, don't worry about that. And a little Oz example here. So still, this piece is still a little bit bare bones. And actually, really, what I'd like to show you more of right now is the Oz side of things. So coming back over here, you'll see just underneath the link that we clicked, it says nREPL server started in port 3850. So whatever sort of tool you're using, you should be able to connect to that. I'm using Vim here. And so what I'm going to do is first evaluate the Polis math namespace in this project. And just want to point out that this is running in the Docker container, right? But with the nREPL port file, it's able to sort of find the right connection into the Docker image with all this stuff sort of baked together. And once this Polis math namespace is loaded, we can then go in and evaluate the user namespace where we have some sort of stubbed out code for starting the Oz processes. Now, it should be the case that you should be able to just immediately evaluate the user namespace directly and have it require math, but there's a little bug that's preventing that from happening right now. So just kind of a heads up if you're poking around at this. So once we get that running, we get a message here, web server running at localhost 3860. So we can go ahead and plug that in here at the browser. And we get this little message saying that it's ready for a spec to load. So the first thing I'll load is a basic Vega Lite visualization with a couple of data points just to keep the wheels here and make sure things are working. But really what we want to take a look at is this Oz build process here, which kicks off this live code reloading process that gives you a sort of notebook-like environment, a little bit more like what you something like between a notebook environment and like a live coding environment with say like Reagent or Figwheel or Shadow if you use to those tools. So once we've got this running now, you'll see that this is looking at the directory notebooks Oz. And so down here, we can open up this file in that directory. And so this is just a regular Clojure file, right? The only interesting thing being that in this particular mode of evaluation, whenever it sees a literal vector form, it will interpret that as hiccup and render it to the page. So all I have to do to kickstart this is save the file. It sees that something's changed, and you can see over here on the right, it's reloading the file. It prints out information about long-running forms that are being processed, as well as how long it takes them to run. And once that's done, we get a visualization and scientific document here on the right. So it looks like I'm right at 5 minutes. I'll try to speed through this here. So this particular data set is from a consultation done in Taiwan around how to regulate Uber in the nation. And so you see there's 1,200 participants here, 50,000 votes, an average of 40 per participant. And we can put all these votes together in a matrix of voter by comment, which is cool looking, but not very useful necessarily. And where this gets a little more useful is where we start applying dimensionality reduction to project this really high dimensional data set into a lower dimensional space that we can visualize. And so here is a PCA projection where we're coloring by some groups that have been assigned using clustering algorithms, and we can interact with that using this hover over here. And here we're looking at another dimensionality reduction called UMAP, which has a little more degrees of freedom for finding kind of finer grained structure. And so just to kind of demonstrate some of the interactive features here, we can actually see how these two projections relate, which is really cool. So I think, yeah, I'll kind of wrap up here. Some longer term goals for the project. I'd like to eventually migrate the core Polis tool itself to this TechML dataset and libPython stack as appropriate. Right now, it's just kind of an experimental place where we can build more custom analyses and tool around and investigate the data. And the other thing I'm really excited to explore is finding a way to take this API and make it something that people can use from the Python ecosystem, so that data scientists, who are more familiar with that, can take advantage of this same kind of core logic in playing around with some of this sort of civic data. So yeah, I think that's it. Thanks everyone for listening, and yeah, look forward to answering questions later. So please let me know if you have any. Thanks.
Thank you. Wow, that was enlightening to see your workflow and the UMAP versus PCA. So much to think about now.
Yeah.
And now the next speaker will be Sivaram. I think, are you here? Oh, yeah, yeah. Would you like to show your screen?
Yeah, thank you, Daniel. Okay. Sharing my screen, and let's see. Okay, are you able to see my screen now?
Yes.
Oh, okay. Thank you, Daniel, and thank you all for having me here. This is my first time here, and I've been enjoying listening to the different talks and the tools. So I'm a clinician. I'm a physician by training, and doing clinical ontology and knowledge engineering. So what I'm talking about here in terms of imprecise data is coming from that ontological perspective. Right? So imprecise, right? It means lacking exactness and accuracy of expression or detail. And so the question is, why do we care when it comes to data? Why do we care whether something is, we want to do things very precisely or not? We do care because it has, very serious consequences. So for example, many years back, it's probably more than a decade now, we had this Hubble telescope which launched into space, and after launch, they found out that the images were not sharp. And then finally, they traced it back to having an issue with, one of the mirrors was designed like with the 1 millimeter difference. And that 1 millimeter flaw led to a huge problem in terms of images being sharp or not. Now, I come from the clinical space, so I want to give you an example from medicine. So we do something called the EGFR, or the estimated glomerular filtration rate, and that is necessary for calculating. That's necessary for diagnosing or staging chronic kidney disease. So the GFR is measured based on serum creatinine levels. The normal values for it run from around 0.84 to 1.21 milligrams per deciliter. Now, there are different ways of doing it, but the main methods are the Jaffe and enzymatic methods. And depending upon which method you use, the difference can be up to about 0.2 milligrams per deciliter. Now, when you do calculations based on this, it can lead to a bigger difference in the results. So the calculated EGFR can vary quite widely depending upon what method you use. And so at an individual level, if you are calculating the EGFR and comparing and trying to see if the patient has chronic kidney disease or not, then you could be off by a little bit. And a patient who is not in chronic kidney disease, you can very well diagnose as kidney disease and start treating for that. Now, source of imprecision in data can be, twofold. One is at the time data is generated, because you're using different methods, different instruments with different calibrations and things like that. But today, what I want to talk about is more on the storage, computation, and exchange of data, where imprecision can be far more insidious in a sense that we don't even realize it. And this is an example. This is something that I found in Java almost about 15 years back when I was working on some data. It is simple calculations using a float can lead to an imprecise number. And I tried to replicate that in Clojure, and 15, 20 years later, it's giving me similar kind of results. So if you add 3.3 to 3.3, you get 6.6. But if you do it 3 times, you get 9.89999 instead of 9.9. The problem with this is, as by itself, you round it, you'll get the right answer. But once you start multiplying it, adding it to other things, subtracting it, do all kinds of computations, the end result can be very problematic. Now, when it comes to dates, I'm seeing that we have a huge issue, and this goes in medicine when we are dealing with a lot of events and trying to figure out what happened before and what happened later. It's a big issue. Now, if you want to create a date instance in Java or in Clojure, right? This is what you get. You get a year, month, date, time stamp, and then the time, and then up to the milliseconds level. The problem is we don't deal with events like in real life up to this precision, right? So you have a birthday, you're typically dealing with up to year, month, and date. Somebody has died, and you're saying, okay, something like in 2008. And if you have a diagnosis, you could be saying, oh, that happened in January of 2011. And when it comes to some things like, procedures, it could be as vague as saying, I had this procedure about a week before Christmas. Now, how do you represent this when you do not, when your precision is, goes up to the millisecond level? So when you say something like 2011 January, I found that different systems, right, different places, they compromise in different ways. They say 2011 January 01 or January 31st, or sometimes they go into the middle, right, January 15th, and they take. So when you start comparing dates, right, what happened before and what happened later, this causes problems. So this is one of the biggest areas that I face an issue in terms of handling dates in medicine. Now, Mike earlier talked about the querying for data, where he mentioned find all subjects with stage 4 cancer and things like that. Now, what does subject mean? What does stage 4 cancer mean? These are kind of things that look very simple, but there's a lot of ambiguity when it comes to the exact meaning of these terms, and that's what ontology is all about. So we deal with a lot of situations where a single term can have several different meanings. For example, the word cold, if you find it in a sentence, right, it could mean feeling cold, or I have a cold infection, or it could mean chronic obstructive lung disease. So here is something that we found in when we're looking at actual clinical data, when we come across a sentence which says like no recent catheterizations. What do you mean? And here are like all the different meanings for catheterization. So so precision is very important when we come to dealing with data, and it's very important to have the exact meaning, whether it is numbers or dates or terms. They all follow the same pattern. It's very, very necessary to have the exact meaning for these things. Thank you.
Thank you so much, Sivaram. And it does open so many questions, but at least conceptually, to me, it helped to see this way you're conceptualizing this. And so the last talk before discussion will be by Lukasz. Lukasz?
Yes, I'm here.
Oh, you're here. Oh, hello.
Can you hear me?
Yes.
All right, let me share my screen. Can you see my screen?
Yes.
That's great. So I'd like to talk about differential privacy, or how you can protect private data with Clojure. Unfortunately, anonymization does not work. Basically, You can cross-reference and de-anonymize data sets. It happens all the time. It's really horrible. So and there are some horror stories you can read online. So we need something better. Unfortunately, now we have differential privacy. Researchers now call it the golden standard for privacy. And US Census has already been using differential private algorithms. Big corporations are doing it. There are more and more open source tools, but the idea is not widely known, which is why I'll try to explain what it is. So the general idea is your private data is safe if a query cannot even reveal if your data is there in the data set or not. So here we have a data scientist. He's looking at some query results, and he cannot even figure out, are these coming from the full data set or one where all your data is missing? And this holds for all individuals in the data set. So the way I just put it is a little too strong. That would mean we have perfect privacy, which does not exist. And it would also mean the algorithms produce, the queries produce results completely independent from the data sets. So that would be useless, right? So this is what we really have. Here's the definition of what it means for an algorithm to be epsilon differentially private. Basically, this parameter epsilon here expresses the trade-off between privacy and utility. So for perfect privacy, we would have epsilon equals 0. This thing would then be 1. And for all these for all pairs of such data sets, we could not distinguish between them. We would not be able to distinguish between the two data sets. So we have to set this parameter to something higher than 0. And but not this value should not be high, but it has to be higher than 0. We call it a privacy budget. And this is still a very strong property. So yeah, so this is the definition and the desired property. To actually achieve this, we need to use random noise. So we can either add random noise to data itself. It's called local differential privacy, or we can add noise to the query results. That's called global differential privacy. So here there would be a trusted curator. So we would send the query to the trusted curator, who would compute the query results from the data set, add the right amount of noise, and send it back to us. So we would have this interactive mode of work here. And it seems this whole differential privacy field is moving more towards this model, where there's a trusted curator and the noise is added to the query results, not to the data itself. So enough noise means we need enough noise to protect individuals' privacy, but not too much so that analysis is still good, right? And even machine learning with differential privacy is possible. It's so fascinating, but I have to move fast. And before I show something that works, I need to talk about OpenMind. We are an open source community. We are working on all kinds of privacy related technology. There will be a free online conference at the end of September. If you're interested, check out those links. I'm a member of the differential privacy team in OpenMind. And we have a little Clojure library for differential privacy. It's actually a wrapper for a Java library by Google, from Google. And there's great value in having this Java library under the hood. Namely, in differential privacy, we have to worry about attacks on implementation. So this is a little similar to cryptography in that way. So having this audited and battle-tested library under the hood is great value in this for us. All right, so I'll show you a notebook real quick. So here's a bar chart showing counts of visits per hour. So in a restaurant, right? So the red bars are showing true, unaltered, real numbers of visitors per hour in the restaurant, and the blue bars are showing the same values but with a little bit of noise. Noise is generated randomly. It's Laplacian noise if you're curious. So you can see the blue bars are slightly different than the red bars. There's some distortion, but not too much. So you can still see the pattern, right? And so even from the blue bars themselves, you can see, for instance, when the restaurant is more busy. And to compute these differential private values, or to add the right amount of noise, we need to use functions from the library. Here's a count function for counting visits, right? So it's basically, it takes a collection, and then you need two extra parameters. The first one is privacy budget, and the other parameter, long story short, means how much an individual can contribute to the algorithm's result. And in general, the more an individual can contribute to the algorithm's result, the more noise needs to be added. I hope it makes sense. It's all about hiding individuals' contributions. So you can compute differential private count. You can compute differential private sum of elements from a collection. Also mean, and some other functions will be available. It's all work in progress. The Java library is work in progress, and the wrapper is also work in progress. And that's it. Thanks for listening.
Wonderful. Thank you so much, Lukasz. And on that too, we will wish to have a longer talk. So these were the lightning talks, and now we have some time to discuss. And now we have 17 minutes to the official end. And for some people, it is late hour at night. But I guess after the official end, some of us may wish to stay more because of all the trouble in the beginning. So anyhow, let us try to be short. And my advice for this discussion is maybe try to ask questions more than trying to answer that is more suitable for this kind of meeting. And let us chat. Anybody?
Yes, I have a question to what is it? In regards to the atomic queries, is there any speed problem in using the atomic for this kind of queries that you are doing?
And that is to Mike, I guess.
Yeah.
That is to Mike, yes.
Yeah, Datomic's not not the world's fastest. We actually are working with Cognitect, who are building like a query optimizer engine for us, since they have something against putting that into Datomic itself. So we've been doing some work on that. So it's not the fastest graph database in the world.
So I have a question to Mike as well. So if I understood correctly, your database has a graph model, or which model if it is on a graph?
Let's see. I'm not trying to understand the question. We have
I mean, actually, my question is, why did you choose the Atomic over another database, whatever it could be?
I think I think we chose a graph representation because it was necessary for the complexity of the domain, of the data domain, and we choose Datomic over another graph database for more social reasons than anything else. That was before my time on the project, actually. I mean, so Datomic, there's other like RDF databases which are sort of from the kind of representation query perspective are pretty similar to Datomic. So I don't know. I hope that answers your question.
Yeah, you have. I mean, my question was which was the model you use? So it's a graph.
Yeah, it's a graph. We've sort of imposed a schema over it, which was the subject of that graph diagram I have. So there's about 30 classes, and a class can have in our case sometimes many hundreds of thousands of entities associated with it. For instance, like I think measurements are the biggest class in Candle, because that represents basically every piece of information you get from a sample. So there's hundreds of subjects, but hundreds of thousands of measurements, and somewhere samples are somewhere in between that. And then and one thing I didn't talk about. So I wrote a system called Alzabo, which generated that diagram and kind of and manages the schema. So it makes it a little bit nicer to to create and manipulate schema level information with Atomic, and that's something I'm working on. I'm hoping to open source soon.
Just wanted to say, I love seeing that you're able to open source the Clojure script. What is it, Blockly wrapper? That seems like a really cool thing for being able to expose, computational functionality to folks who aren't, ready to dive into code yet.
Yeah, I'd be very happy to hear from people who are using that or help them get started. It's Blockoid, by the way, is the name of that library.
Yeah, I think I have some kid projects in mind.
So I'm just curious about if people are doing any work around using directed acyclic graphs, any particular libraries or anything that you're using for that work. So most of the ones like Vega Lite and all don't have that functionality. You have to dip into either D3 or something else. Like I think Loom is another one that has some functionality, but otherwise there's not a whole lot of choice out there.
Yeah, I think you can use Vega for doing some of that. You can do some graph work directly from Vega Lite, and some of the layouts have gotten a little bit better there recently. I'm always pitching Vega. The team is just, one thing I love about them is the team is just so responsive to requests and questions. And I had thrown out, I was trying to build a phylogenetic tree visualization toolkit and didn't have the right layout to kind of make things look right for a phylogenetic tree. And they added it like, I don't remember, it was like a few weeks later, like it was pretty awesome. But yeah, I think you can, I'd have to look, but I think you can do, if you can't do it with Vega Lite, I think you'd be able to do some basic stuff like that with Vega.
And you can do, I think you're right, like basic stuff, but I've talked to the IDL folks as well about some of this, and they realize there's a lot of limitations there, and it's just not high on their radar. It's not something that's they're really going to get on the roadmap very soon. The thing that I would suggest is probably Cytoscape. That's probably the best graph thing out there for visualization. Yeah, you can do, it's just amazing what you can do with it.
Yeah, I've looked at Cytoscape, but then decided to experiment with D3, stick to D3 and experiment with that.
All right. That sounds much more low level, but okay.
Yeah. Now,
wonderful.
Now, I'm not a programmer or a developer, so I do most of the Clojure work from a hobby perspective. And so one of the challenges that I find is, you guys are showing some amazing tools and all that stuff, but the learning curve to get set up with any of these tools is quite a lot. And if you're not working with them constantly, then it's really difficult to wrap your mind around it, to see how it works and all that. So I think one of the things that will help is if there's any chance. I know a lot of this is like open source voluntary work and all that, but it will help is if you can put together a small hello world kind of thing for each of the things, and go from there. Take a single example and make it more and more complex rather than giving different examples. Just my 2 cents.
Yeah, I think there's actually two pieces to that question or point. One is the idea of getting the infrastructure up and working at all. And then the second part is understanding the details of the particular system or library or whatever. So those are kind of two different things in my mind. For something like Cytoscape, you really just need Java 8 right now. It still hasn't really ported to 11. But that's all you need, and it's a self-contained Uberjar. And it will even install the MKL libraries for Neanderthal for you. So you don't need, I mean, well, you still have to, if you know Emacs, it had all the editors are all basically Emacs like. They're not Emacs, but they have all the CIDR type bindings. You can configure all of that stuff if you want, but it has all those as kind of default bindings. And you can use Vim if you're a Vim person, or Sublime if you're that. So all of those are available. But the default out of the box thing, Emacs, CIDR.
Yeah, maybe I will comment about that. I think, yes, one of the problems we have is that many of the tools and libraries are not yet accessible enough. And that is the stage where we are at. And I think a lot is still missing in terms of functionality in the ecosystem. And what we may imagine is that after several months, some of the missing pieces will be there. And then we hope we will be able to focus on writing tutorials, being able to reach out to more people and try to make things easier. But I wonder, maybe also worth mentioning here is that Ashima, who is in, she's writing tutorials, and some other people are writing tutorials, and we are kind of in the beginning of this stage, and I hope that in a few months things will be different.
Yeah, if I can add something to this too, I think and I didn't have a lot of time to touch on this, but one of my goals with the Docker environment that I put together and demonstrated is that while I think as John Anthony was pointing out, like Clojure, by virtue of being on the JVM, is pretty good about just kind of running and being sort of repeatable and not being different on different systems, et cetera. But now that we're kind of bridging out into this space of creating better interfaces with languages like Python and R, some of those environmental, especially with Python, some of those environmental kind of complications can be quite challenging. I mean, if you've worked with Python for more than any period of time at all, you've probably had an issue with virtual environments and this version of that not working with that, and it's still a mess there, unfortunately. And so one of my goals with this was just to put together this package that it's all baked together. You've got it's all baked into a Clojure jar. So if you like using it from the kind of notebook environment, that's easier for some folks to get started with, then you have these tools put together there. If you want to branch out into kind of working more directly from a REPL connection, as I was demonstrating, and as John Anthony was kind of pointing out, then that stuff is all kind of there for you too. So I'd encourage people who are kind of interested in building environments like that. I mean, I realize what I put together here is very kind of specifically focused on these kind of Polis data sets, but I'd love to see people taking kind of the guts of that Docker environment and sort of repurposing them for other uses, because I think that there's a lot that we can do now that we have this ability to stitch together these different ecosystems, but it's a problem if you have to set up those environments yourself. I mean, it's hard enough to set up a Python environment, but setting up to merge with Jupyter and with all this Clojure stuff can be a little bit daunting if you're not oriented. So just throwing that in there.
Yeah, I totally agree with that. I do. On the other hand, I would say Python is hands down the worst. R isn't anywhere near as bad.
Yeah, I agree.
But on that, may I ask Sivaram, like whether or not you have like some sort of a reference point, right? When you say like maybe getting started is not as good in Clojure or is not as easy, like you have, what are you comparing that to? And what is it? Is it the tutorials? Is it the Docker container that would make it easier?
So I actually love working Clojure. So I had actually given up on doing any programming work about 10 years back. So before that, I used to do do a lot of stuff in using Java mainly, and then I got tired of Java with all its verbosity and everything. Right, it was painful to set up and take down every single thing. So moved more into management, but of course, you know, the development itch was always there, and then came across Clojure, and yeah, it was a steep learning curve, but I stuck to it, and I actually enjoy working with Clojure. So pretty much everything I do now is in Clojure, and so it's so don't take me wrong when I say that, you know, there should be better tutorials or better hello world kind of things. I think it's even after 5 years, I find that, you know, with some of the new libraries, when I want to bring them in and start using them, it's not that easy to get up to speed with them, and many of them don't seem to kind of like work in the way that that's described. Maybe it is because of version differences or whatnot, but there are still challenges. Now, a lot of them work very well. It's just that getting up and running with them can be made a little bit more easier.
Yeah. I don't want to segue off this topic too much because I think it's an important one, but there are some questions I wanted to sort of throw out there around some of the kind of interactive features that, in particular, what you were kind of demonstrating, Daniel, as well as what you're working on, John, and some things that I've been thinking about for Oz. So I guess I'll put that out there that I'd like to, at some point, ask some questions about that. But I think I'd also like to leave more space if folks want to continue talking about this particular thread.
Well, I'm enthusiastic to hear the answer to your question because my experience in data science is detecting the difference between comma-separated and tab-separated files. So, for example, I think that I've seen 3 different notebook kinds of solutions demonstrated here, either as the main event or some factor in a presentation. Was there Clojure and Oz and Scicloj and Tablecloth, and I'd be interested to learn more about what they're based on and how they differ, how you choose which one, what's possible to accomplish, whether their strengths are mainly in the discovery mode, like a REPL, a rich REPL, or a presentation mode, a supercharged PowerPoint.
Yeah, so I guess one way to address that is to have a sequence of small meetings where we will be discussing each and every tool of these. I think both Scicloj and Oz have had some detailed presentations that are available in video, but they have evolved since then. And yes, we need to keep describing what we are having here, and let us have that in furthermore meetings. We are now at the official end, and in a moment we will say goodbye. Does anybody wish to say anything else before the goodbye?
I have a quick question for Lucas, perhaps. Maybe I don't understand it well enough. I actually have access to a large number of customer contact center transaction logs involving, digital chats, phone calls, web self-service sessions, etc. I was wondering if his privacy package might be applicable to create larger and scalable data sets sufficiently protecting individual privacy, or whether or not that's not the purpose of the library. I'm just curious about whether it could be applied that way.
So it's not production ready yet. Can you hear me? Yeah. So yeah, this is exactly financial data, medical data, data about crime, this type of stuff is exactly what we care about, why these tools are there. Yes, so in general there is this need to protect some data, and at the same time somehow allow analysis, right? Or even machine learning. Like there's so much we could do with machine learning on medical data, for instance, but it's all locked. It's somewhere there in hospitals, and it's for good reasons. It's protected, it's private. And the same thing with financial data. Yes, that's exactly what these things are for. What I just showed you is something very small. It's all work in progress, not production ready at all. But I encourage you to go to openmind.org. We have all kinds of solutions there. There's the educational materials. We're all about that. We want to lower the barrier to entry to all these privacy preserving technology. And AI, data science, we offer teaching materials and open source tools for free, also consulting. So go check out those links.
Yeah, and if I can ask my question of Daniel real quick. So you had the thing with the slider. I think this is maybe hopefully a short question, but you had the thing with the slider where it updated the visualizations, and you made it sound like the slider was updating state on the server, or in the JVM process, and then that was triggering processing that flowed back through to the browser. So you said that's using JFX, is that right, or JavaFX?
Yes. Yeah.
Yeah.
So can
you say a little bit more about like A, how that works, and B, like what the API looks like for that, as far as like when you're creating your note space, how you actually wire those things together?
Perfect. So I will just say briefly, and afterwards I will just make a video about that on one day. I guess we have seen different dashboard-like systems today. One by John, which was magnificent. And what John was showing us was how we can manage state in the browser, in the client, and use the backend JVM just for computation and as a data source. And a similar library that does that, this way of dashboard building, is called Goldly by Florian and Andreas, who are here today. And it is also worth looking into. And what NodeSpace does is different. NodeSpace uses the state of the JVM as the dashboard state. And it is built for a different use case, not for building dashboards which can be served in the web to many users, but as a tool for one person with the REPL. And the idea is to connect the browser and the REPL. And then, indeed, the challenge is to manage state in the JVM. And our friend Vlad has built a Clojure library called CLJFX. It is a wrapper of JavaFX for building desktop applications. But NodeSpace does not use the whole CLJFX. It only uses the core of CLJFX, which is used for managing state in the JVM. And this core is similar to what you may see in ClojureScript libraries for client development, but kind of different and refreshing in a sense. It is all around pure data transformations. And it is really a beautiful model worth looking into. So you can look into context and subscriptions in the README of CLJFX, and everything is there. And we will discuss it further soon. So thank you for that. And I guess maybe that is a good moment to say goodbye. And thank you so much for everybody here who have been here in unusual hours in the end and beginning of their day. And I guess after the goodbye, we can stay and keep chatting and keep recording if you wish. But at that moment, thank you so much to everybody who needs to leave. And see you next time. And we're only scratching the surface, of course, and we need to talk again more and more. And now let us keep chatting if you wish. So anybody, any topic? any question or thought?
I have a question which has actually nothing to do with the data. I've started working with Clojure like a few years ago, but I'm still a beginner because, as Sivaram said earlier on, when one loses the rhythm, if you don't use all the tools every single day, you forget about how to use them. So my question would be: is there some kind of mentoring activity around, and anyone knows about? I mean, I know there's Clojure Farm. I've signed up to it. But unfortunately, the problem is that there weren't enough mentors. So it's a little bit disappointing that, I mean, it's nice to have at least one person who knows more than the rest, so that person can, lead and help the others. Yeah, that's mainly my question. Nice.
I think Theodore knows something about mentoring projects, right? Theodore? Or maybe I'm wrong.
Well, we did try to do some mentoring work on Athens. I was involved in Athens development for a while, which is a tool to build a knowledge base, a clone of Rome, basically. And our strategy was to get more Clojure developers by teaching Clojure. And then we tried to match up mentors and mentees. And it seemed really simple on the surface because we wanted to make something that was scalable, and we just needed to attract people. But when you get into the weeds, it gets difficult to organize because you need really invested mentors and really invested mentees. And what do you do when some people sign up and don't really want to contribute, and other people have different motivations in mind? But that's the low end story. There are cool parts as well, because sometimes they just strike it off and it works fantastically. For a while, I was doing code reviews on a mentee who was working through Clojure for the Brave and True, and he put his exercise in a gist and later on YouTube, and then I did code reviews, which was interesting. Yeah, so an interesting experience. I don't know whether that really answered your question. I don't think I understood perfectly what you were asking for.
Yeah, in fact, Clojure Farm, I think it's organized by the same people from Athens. So,
yeah.
Yeah. Actually, on that line, I've tried to figure out where in Gitter or Clojure in Slack, or whether it's some kind of Mastodon group or whatever. I've posted a number of different questions, even on Reddit, and I'm not able to figure out yet exactly where the right place is to ask questions.
About Clojure Farm?
No, not about Clojure Farm itself, but just specific things that I get blocked by, and I'm expecting somebody would have a quick answer. And some of those forums have dozens of people signed in, but nobody really active. So I'm just trying to figure out where the action is taking place.
I found many answers in the Clojurians Zulip channel.
Okay, Zulip, okay.
I asked in the beginners thread, and I normally would get answers right away, actually. Very useful answers, by the way. So Thanks. That was very, very important, and it's very rewarding to know that if you ask, someone will answer.
Yeah. Oh, look there. So, I just want to echo Sivaram, I used to be a Lisper way back when Interlisp was my favorite language. and on a Xerox Dorado 36 machine. But you know, in the intervening years, I got tired of Java, and it was very verbose, and you know, the whole rich message about that was right on. So I just recently, just 5-6 months ago, re-engaged with Clojure, and I'm having more fun than you are, I suspect. So I'm really trying to get back into it myself.
Beautiful. Leandro, I just wish to say that I remember your ideas about mentoring and the discussion we have had about it. And I think you have had a beautiful vision of how we could organize a mentoring system where we could help each other. And let us try it out. I think it will be challenging, as Theodore said, and the challenging thing would be to find some continuity, some people who can commit to a process, and let us keep trying.
Yeah, actually, I got into Clojure. I mean, like the strongest way in which through which I got into Clojure was via a Clojure developer I met here. He was living here in Buenos Aires, and we got together and we did pair programming, and it was really awesome. And it was very important to have someone to ask about, how do you do this simple little thing in Emacs? Like this way, okay, then okay, I'll keep on working. So things like that. I mean, sometimes it's not about asking like big questions about the language or the ideas or the paradigm, because I mean, for me, that's not really very difficult. But what really makes the difference, at least for me, is to be able to have a fluid workflow. For instance, like a couple of days ago, I was swamped because I wanted to create a new namespace, a new file actually, and I wanted, and I was asking myself, isn't there a way to automatically create it, like so Emacs will take care of it, like Eclipse does when you want to create a new class, something like that, like that. And I ended up doing it by hand. It was like quite annoying. I mean, because I didn't know how to. Probably there is a way, but I didn't, and I don't. So things like that. I know there are also there's very good documentation from Practically. That's a very good project. I like it very much. But yeah. I mean, of course, it cannot cover everything, and those are the things that I could not easily find.
Yeah, if I can throw something out there, I feel like there's I think kind of the key to finding, and this is kind of in response to your question, Sam. I think that there's a little bit of a it's like sometimes it's not just finding the right place, but like the right space within the place, if that makes sense. So for example, if you're on the Slack Clojurians group, you know, you might ask in a general room some kind of question about whatever and really not get much of a response, but then find that there's actually a more focused group somewhere, say talking about DataScript or Datomic, where you can get answers to questions really quickly. And so I think it depends a little bit on the community and like what the particular question is. And I wish I had a better answer than like find the right place. But I think for the data science community, a lot of us are on Zulip now. There is, people are still on the data science channel in the Clojure and Slack, but there's a lot of activity in Zulip as well. And so, yeah, I think it kind of comes down to what's the question. And I think sometimes with tooling questions, which they may feel sort of ancillary or, you know, secondary to kind of core questions about how things work in the language, say, but they're also really important, right? Because those little bits of, you know, I mean, so much of my workflow being something that I can be fast and effective in comes down to just how I have my editor and my environment set up, right? And it's sometimes hard to know where to ask those questions. But yeah, so I just say like poking around and, you know, not being afraid to ask in multiple places sometimes to kind of figure out where what questions get answered with what frequency is kind of maybe the best advice I could give. And also, I guess one further thing, like asking questions on Stack Overflow, I feel like, I don't know, maybe doesn't quite happen as much as it used to in the Clojure space, but it's great that when you do ask questions there, if it's like the right kind of question, you know, those things are then really easily searchable, which is nice and can be improved upon again, you know.
Isn't there that new Ask Clojure thing that Cognitech put up or something?
Yeah, I haven't used that at all, really.
I mean, I mean, it sounds good, but I don't think I've ever even been on it.
Yeah,
well, do check it out. It is especially useful if you have the suspicion that your question might lead to a JIRA ticket against Clojure or Clojure script, right? Because it seems to be that the Clojure JIRA is browsable publicly, but I don't think just anybody can submit a ticket. So ask.clojure.org is a very nice way of raising a question which might indeed have a useful answer, but in case it doesn't, the right people will notice and echo it in the ticket in their JIRA. On the other hand, if you are looking for more conversational answers, there is a website called Clojureverse, which seems to have taken up a lot of the activity that used to be on the Google Clojure group.
Yeah, the Google Clojure group used to be kind of the place to go, I think, and that has, I've noticed way less activity there, so that makes sense. That's kind of where that's gone.
Wonderful. Anybody else wants to raise some topic, idea, question, issue?
Is it planned another a meeting like this one for the future?
Could you repeat, please?
Do you have plans for the following meeting? Are these meetings regular?
Yeah, so we are thinking about it. First, let us say that all this community activity is open to anybody who wants to take part and influence how we are going, where we are going, how we do that. And so if you have any opinion or thought about what we need to do as a community, let us talk. And yes, it is planned to have public meetings of this kind every month or two. Next time will not be at this hour. It will be on an hour which is more comfortable for the friends in East Asia, which is earlier. And what we are planning to do more is small meetings, like a small interview of one person telling their story and a few others listening and asking questions. This kind of format is something that we are going to do more because we want to have also more focused discussions alongside the public ones. Does it make sense? Any thoughts about it?
Yeah, sure, because it is wonderful to have the chance to have access. I'm living in Buenos Aires, Argentina. So here the Clojure community is almost non-existent. So having the chance to have direct access to more major communities all around the world is wonderful for us. So that's why I'm interested in keeping in touch with you.
Yeah, perfect. Let us have it more.
Yeah, sure.
I'll add that while I really like having kind of more focused sessions on, you know, one person talking about a thing that they're doing, being able to dive in a little bit deep on that. It is also really refreshing to every now and again have something kind of closer to this format with lightning talks and a little more open discussion, because you can kind of like take in a more bird's eye view of what folks are working on, and it's been fun today to see that from folks.
Yes.
Yeah, I agree with that sentiment too. And regarding the smaller meetings, right? What about something like doing workshops on a regular basis where one person like Chris or somebody can go with the tools that they're doing and start from scratch and build up a project and work through some small, well-defined problem in a couple of hours. And,
yeah, I love that.
everybody else can follow along with that.
Yeah, that's great. And that seems to thread into some of the other stuff we were discussing with, how can we onboard more people? And I like that idea.
Sifram, do you mean to have an open workshop of this kind, or something that is recorded and shared afterwards?
I think having it recorded, I think, is always useful, right? Because we can, a lot of times it's, you want to follow along, but it's not that easy many times practically. And you may want to go back and pause it, get your environment in order, right? And then start, continue from there. So I think recording it would be really useful. And part of the reason is that, when you have a workshop kind of a thing, you have some discussion going on. People are asking different kinds of questions, right? And I think that adds to the value of the discussion, of the workshop itself, rather than somebody just giving a tutorial which is one-sided.
Yeah. I mean, I'll suggest one example. I mean, I don't know what I've been doing. Maybe I've been trying to use Java 14 too soon, but I can't get Gorilla working. So maybe I've got to go back to Java 8 or something,
Gorilla doesn't work in anything other than 8. So.
So I didn't read the fine print there.
Yeah. I mean, it's kind of a problem because I mean, like Scicloj doesn't quite work in 11. I guess isn't 11 the largest version that Clojure Cognitic actually claims to officially support?
Yeah, I think so. I think what happened was that there were some changes to what libraries came prepackaged with Java between 8 and 11 somewhere. And so it's subtle things, because while Clojure, I think by itself is great at maintaining backwards compatibility and things kind of just working years later, if something breaks in the underlying, or if something changes in the underlying Java system, you're kind of screwed. And so I think there hasn't been too much of that, but it's funny how just the one or two things that have caused friction, they seem to kind of grate again and again. So it's a hump to get over.
When they changed that whole, I guess they try to call it security model, the privacy model between packages and stuff, from 8 to 9. That was a complete mess. And really, I think that was one of the dumbest things they've ever done. But I guess if you can get past that, then, things like 11 going, big difference between 10 and 11 or 11 and 13 or whatever is not that bad. It was that 8 to 8 plus that killed everything. I mean, it's amazing how many things just don't even work on 9 or like 9 plus. So like Scicloj doesn't really. I mean, it kind of works like on 11, but not really. And it's mostly because they just haven't went in and fixed all these things that the JVM broke. And, and as bad as it is, I mean, I guess from surveys, it looks like something like 70, 80% of all JVM shops still run on Java 8. Mostly because of this, all their code breaks if they move to something else.
I think Datomic still runs on 8, right?
Yeah, I don't know, maybe. Only runs on 8? Yeah, it's a big possibility, yeah.
So from where I sit, if anybody wants ideas for workshops, connecting to, one thing I mentioned earlier, connecting to SQL Server 16 or 19, or setting up a notebook or a note space style interactive environment, or any kind of integration with libpython CLJ, and just getting that just basically working. I mean, I know there's some README stuff there, but even little gotchas like, I didn't get this version of something right would help unblock me. So those are 3 specific things that I'm going to work through that this week. So anyway, anything that could be done there, I think would help unblock me.
Yeah, there's definitely stuff that I put together, like these documents inside. You can just save these things and push them out to GitHub, and then just load them from any given running instance of the thing. And there's definitely versions, definitely notebooks out there that do JDBC, next JDBC stuff. It doesn't connect to, I mean, I've used it mostly on like MySQL and Postgres. So I haven't actually used it on SQL Server. But I actually think next JDBC is really a solid piece of work, and and it's not very high level, so it's not like it's unlikely that the only thing you'll need more than just the you know, the adapter for the database. That's probably the only thing you really
Even that was the question. You know, just getting MS SQL JDBC 7.3.1 took a few days to figure out whether it was that or 8 version 8.
Oh, well, yeah, okay. Who knows? Yeah. And I have documents that run with Clojure, but it does require, as Chris points out, this, you know, these extra environment things having to do with other ecosystems are probably much more painful than anything associated with Clojure, the JVM. I've had, you know, with R, I've had pretty good luck, except on the Mac. Even the Mac is just, Apple has just become, I actually think I hate Apple now. And probably would be more willing to go with Windows, except that everybody in the labs uses Mac, so I have to kind of stick with the Mac. But R on Linux is dead easy. It just works. You don't have to do, and I mean it's like a no-brainer. It's a complete no-brainer.
Yeah, maybe I'll comment about that. I'm part of an R team. We are maybe maybe 7 or 8 people, and except for a couple of us, everybody used Macs. And the idea was to have kind of a standardized environment so that we can avoid all these setup problems, but we cannot avoid them. And we use Dockers as much as possible, but there is so much about setup. It is taking like a decent percentage of our day just to cope with installing our packages and making sure that things are unified and standardized. It is never ending. And I am amazed by how easier it is on the JVM by default.
Oh yeah. Yeah, I mean, the difference is light and day. I mean, it's just crazy, the difference. And Python is way worse than R. I mean, it's like beyond bad.
Yeah, I think there are a lot of fundamental assumptions baked into Python and how it thinks about libraries that, I mean, I think the original sin is just you cannot install multiple versions of a library in the same environment, which like that's so, I don't know how many decades ago now. But whether you look at, you know, obviously Clojure or Java or you know, NPM and JavaScript, I mean, that's just not, you know, we don't have these problems anymore, and they still haven't sort of, and from that we get virtualenv and, you know, all these other challenges. So yeah, it's a challenge. I'd be interested, and I think, yeah, the other thing that has occurred to me just recently, we had this Docker environment working, and all of a sudden someone tried to run it and it stopped working. And it all came down to, well, one of these pip packages had updated, and now they were compiling against a different like lower level, system library, and now nothing was working, right? Because it couldn't bind to that. And so, you can tell people to, well, just include the versions of whatever pip packages or whatever you want to install. But there's there's something really nice about languages that just force you to, or environments, I guess, that force you to include your versions when you make your declarations. It's something I've come to really appreciate with Clojure. You just cannot specify your dependencies without saying what versions you want to point to, and it just kind of forces us all into the habit of like, oh, now this thing's repeatable. So yeah, I think that it doesn't solve the problem once we start trying to interface with the rest of the world, but it is it's something that's nice that we have, at least in our core kind of ecosystem. So I'm interested in thinking about, I mean, I don't know if like Docker is the only answer to this, and it's just like we just have to make a container for every possible like configuration of environments we might want, or whether there's some possibility of us kind of bringing a little bit of that sanity that we have in the Clojure world to maybe not to these other worlds by themselves, but at least to the way that we interface with them. I mean, it'd be sort of wonderful if we had an extension of like adepts.eden, where you could specify the say the Python packages you wanted, or the R packages you wanted, or whatever, and that maybe it even forced you to specify the versions, so that so we get a little bit more of that repeatability. I don't know if then you'd have to like, maybe you would have something that wrapped virtual env or constructed Docker images for you or whatever, but it's interesting to think about how we could sort of improve upon that situation.
Another thing is that I've looked into a little bit recently, and I've talked to some other people for like data science stuff in particular, is Singularity instead of Docker.
Yeah.
Because Singularity is kind of geared more towards just a big blob that will run your stuff. Everything is in it. Whereas Docker is a bit more of a DevOps kind of a thing.
Yeah, I've when I was last working at the Hutch, some folks there were starting to use it kind of in the bioinformatics space, and seeming to find that it was a good fit for that.
That Singularity?
Yeah.
It just, because of all these ridiculous, especially in that space, like I have this thing that one of the PIs wants to start pushing out to other labs, and it was like, well, I mean, it's an environment problem, because it depends on zillions of these C++, typically C++ packages, and they're all, trying to build these. You can't run it across operating systems. You can build all the binary, you can build all that stuff. It might work across, if you build it on Ubuntu, it'll work on different versions of Ubuntu, but it won't run on CentOS or whatever.
Can I jump in with a question about?
Just build this bundle that has everything as a binary. And that's what the Singularity thing seems to be about.
Can I ask a stupid question of what Singularity is and how it's different from Docker?
Maybe I can get a link and put it in the chat. It's a container. It's a container thing. So in that sense, it's like Docker, but its emphasis is different.
Yeah, I wish I had a better answer. I never dug too deep into it. But it seems, I mean, I guess it seems more flexible, I think. And I'm trying to remember whether it was, I'm trying to remember what it was that was making folks sort of switch to it at the Hutch. It might have had something to do with like ease of access to, say, local data files, or sort of like.
That definitely.
So crossing the sort of file system boundary was something that was a little bit easier. That might have been one of the main appeals of it.
It's definitely one of them, that's for sure. What is this thing?
So is this a government organization? It says lbl.gov. for singularity?
I think it started out as that, and now it's more of an org thing or something. I got it here if I could just get this stupid Mac to do the right thing. Here it is.
Yeah. So maybe, I guess let us continue for a few more minutes, if that is okay. I will have to leave soon, and I guess everybody are invited to stay. Is there any other topic that we wish to discuss today?
Can I add one thing for Teodor's question? One thing I remember also being an issue is that if you're on like a shared compute system where you don't have sudo access, it can be sometimes difficult to get Docker set up to work in those environments. And that's, I was just skimming through here, the docs, and that's one of the other things I think was appealing to folks about Singularity, is that you can kind of set it up a little with less permissions or lower permissions.
Thanks.
So I put a comparison between Docker and Singularity. I think that's in there. Huh. Let's see if it works. Yeah, it looks like it's going to. I mean, there's a bunch of other stuff on it too, but I mean, that gives you a bit of an overview.
Maybe it is an opportunity to mention that there are some smaller alternative systems for creating reproducible systems. One of them is Geeks, that we have discussed in one of our previous meetings. Geeks is a package manager written in Scheme, in Guile Scheme, and it is based on functional programming principles and allows for very flexible ways to build reproducible systems. And there is also some new project called Hermes, which is like Geeks, but written in Janet, which is a Clojure-like lightweight language. And all these, I guess, are worth looking into, even though they are maybe less popular.
What was the second one again, Daniel?
Yeah, so I'll share the link. One project is...
I've just sent you a link to the chat.
Yeah, so one project I'm sharing is Geeks.
Mm-hmm.
And, oh yeah, thank you. And another is Hermes that I'll find in a moment, which is something really new, and it is like Geeks, but written in a Clojure-like language, which is called Janet. That is Hermes. And I guess at least it could be interesting to learn and see how people are building this kind of reproducibility systems based on the principle of immutable data structures in Lisp.
Daniel, I cannot see the link in the chat.
Oh, that is interesting. No.
Press harder.
Press enter.
Now, here it is. Thank you.
It is, yes.
That worked.
Okay. Is there anything else that we wish to discuss today?
One quick question. What are people using for doing like machine learning and deep learning work these days? So the ones that I found were things like DL4J or Apache MXNet. But again, the Clojure versions of those are either not available or broken. I think some of the older versions are available. So what are people using for this kind of work?
Are you talking specifically about deep learning?
Yeah, deep learning and you know, MLDL, any of those kind of things.
Yeah, so the SMILE library, which is what it stands for, but it's one of the things that's backing the TechML dataset. the entire TechML stack. And it has some great stuff in there. I was really surprised to find out that it had actually implemented UMAP, which was implemented in Python, and so I thought it would be forever until we had something kind of in native Java, but was sort of stunned to find that he'd done the work there. There's also there's.
I just wanted to agree with you, Chris, that the smile thing via TechML is really nice.
Yeah. There's also, of course, with libpython CLJ now, we have access to anything that we'd have in Python, and we've seen some great examples from Karen Meyer, who was on earlier, of connecting to different, the original UMAP, and I think Keras and some other kind of Python libraries. There's also she's also working on the Clojure bindings for MX. MXNet. And
yeah,
I didn't
that's
heard anything about that. Sorry, what was that?
Area that I find are, there's it seems to be there, but when you actually go to the websites and check them out, the Clojure versions are not there.
Yeah, she's dropped off now, so she's just not able to tell us what's going on there. To my knowledge, she's still working on that, and that's still. At some point they ended up featuring Clojure on like the main MXNet page as like supported language. So I think that one of the arguments some folks at least have been making about the kind of value proposition there with MXNet is because that's an Amazon sponsored library. You know that it's going to run well on like Amazon Web Services, right? So this kind of deployment path issue from getting to your development environment or kind of data science exploration environment to something that could be kind of productized is going to be a well-trod path. So it's one argument that I've heard folks make for the MXNet route. But yeah, I think it kind of depends on what specifically you want to do. And I'm a little bit, I don't know, I'm a little bit, I think there's an extent to which like the deep learning stuff has taken a lot of the air out of the room from other really interesting stuff that's going on in the machine learning space. So, with stuff like, again, UMAP, there's this other kind of interesting dimension direction algorithm called TriMap, which, again, actually Karen Meyer pointed out to us. And, there's a lot of stuff out there. So
UMAP,
so it's.
Do you mind a link for that somebody can share?
Yeah, I can. So it's the second of the dimensionality reductions I showed off in the presentation, but let me see if I can get the Python thing for it. Yeah, and actually, I'm not sure whether I should share the. I'll share both the like the read the docs page, and there's a link there to the academic publication, which I highly recommend anyone read who's interested in math, because it's a fascinating paper. It gets into a ton of really cool category theory and like topology and stuff, geometric topology, or what is it? Geometric algebra, algebraic geometry. Yeah, it was just, it was sort of refreshing. I feel like so much kind of machine learning ends up being just very matrixy, and it's just really cool to read a paper that's got a bunch of really interesting category theory and stuff.
Excellent, yeah.
And maybe one more link worth sharing that I'm sharing now is to the Deep Diamond project, which is a work in progress Clojure library for deep learning by our friend Dragan.
Yeah, I'm really excited to see what he's doing with that.
Yeah, I totally agree. It's kind of amazing how far it's come along.
Yep.
Is anybody using it?
I am not directly using it, but I do use Neanderthal. So.
And that's pretty low level stuff, right? So matrix math.
It is matrix, but there's a fair amount of high level stuff in it.
Okay.
I mean, yeah, I mean, in general, though, if you're going to try and use Neanderthal to build a deep neural net or just a neural net, then you'd have to do what Dragon's doing in Deep Diamond. Yeah, so it's more the low level stuff, but I just I used it in some doing large scale entropy calculations across a bunch of genomes.
Yeah.
And I doubt that there's anything else out there other than maybe like TVM that's faster. I don't care, forget about it, you know, NumPy or any of this stuff.
Yeah, he's put out some really impressive benchmarks. It's been really cool to see what wizardry he's been cooking up.
Yeah, it really is kind of amazing.
Yeah.
And it's so nice in the sense of how you can do this. You can even do GPU programming in the REPL. Just sort of try things out. It's really impressive stuff.
Also impressive is that Dragon has made his work function with not only the Intel, but also the AMD hardware.
Yep.
Or the NVIDIA and AMD hardware and Intel hardware. So that if you're not aiming at Amazon Web Services, if you're aiming at desktop or laptop computers, just about any desktop or laptop computer might work nowadays. That is with a certain level of computing functionality in the GPU.
Yeah, I think that's right. Actually, we use it though. Some of our servers are GPU servers, and it works there.
So how about doing some kind of workshop, which where you take what Dragon has done, right, his libraries and things like that, and doing something fairly simple like Word2Vec or Doc2Vec or NLP kind of stuff, and you know, as a both to be able to, you know, for a lot of us who have not used these things to get up to speed with it, and also like it's a good tutorial on the whole data science pipeline also. Well, does that sound reasonable?
It sounds like a great idea.
Yeah,
I'm there.
And maybe, you know, like Chris, you mentioned Smile, right? So to use something like that, and I think what would be useful is the challenge I think with any Clojure library developer faces is that which library to use, right? Heck, even with the dates and times, do you want to use Java time or Java time or which one? You know, so something, just using Smile and Neanderthal or any of those other libraries, you know, maybe 1 week do this, 1 week do the other one, and on the same data set for the same outcomes, you know, you want to do that and see how they work out.
Yeah, I think one thing that I think it's becoming like, I mean, Chris remembers the TechML stuff is a great umbrella. I mean, actually, I haven't tried this myself just yet, but he announced how he's folded Neanderthal into the TechML as well.
Yeah.
So that, I mean, that I think is going to be something that I am really going to use. I mean, it's just a great idea. And it's super cool that you know, TechML sits over the top of Apache Arrow now and Smile and all the. It's a very nice thing. And if you put that together with Tablecloth, you get this dplyr-like API that you might be familiar with from R.
Yeah, and to add to that, it's also has really good interlinking with the libpython CLJ stack, which he also wrote. So not entirely surprising there. But yeah, it's 100% echo everything John just said. And in fact, that's the reason why in this, you know, new sort of analysis notebook stuff that I was showing off, that's exactly why we're kind of going the TechML route, because recognize that we go that route, we have quick access to all of the Python CLJ stuff, and that, you know, those, and as well as Smile, right, because it's built on top of Smile. And so, and again, connecting to Neanderthal, you got that there. And so those three, and the Parquet and stuff, I mean, all those things kind of collectively together, I think it's kind of rapidly becoming a sort of go-to place for, you know, get your data in and being able to do a lot of stuff with it pretty quickly. Yeah,
I'm moving everything that I can over to it.
Yeah.
And now with the you know, data sets that don't even fit in memory, the capability has there. That's, I mean, it's a game changer. And given, and is Anthony still here? Maybe not. But you know, with the Guinea, that he was really cool because he included in that benchmark the TechML stuff. And even with the thing that just floored me was even the you know, the very idiomatic kind of tablecloth, you know, dplyr API version in TechML was almost, I mean, it was within a few, just a tick or so of data.table.
Yeah.
In terms of raw speed. And data.table for me is, you know, it's always been sort of the gold standard for, like, there's hardly not going to be much out there that's faster than that thing. And it's just, it's a lot nicer to use than going into the R stuff.
Is there any other topic that we wish to discuss today?
I think I'm probably done.
Yeah.
How are you going to decide the date and time or hour of day for the next meeting?
Yeah. So I guess next time we will have to do some kind of survey among the people who are not here, naturally, so that we see what would be comfortable to the people who couldn't make it on these times. And certainly we need to diversify the times across the day. And we just have to have enough meetings so that everybody can attend sometimes. So does it seem like a good time to say goodbye?
Thank you very much, Daniel.
Daniel, it was wonderful.
Yeah, so thank you, everybody. It is really amazing. You know, many people here were in the middle of the night and early in the morning. And
as a returning listener.
Yeah, and thank you so much for this meeting. It is really heartwarming. And see you again soon. Let us talk.
Absolutely. Thanks, everyone.
Thank you. Bye-bye.
Thank you very much.
Appreciate it.
Bye-bye.